Dear students, let me start from where we had stopped in the last video. We were trying to characterize bipartite graphs, and we are in the converse part of characterization theorem, which means that we have assumed that G is having no odd cycles. Then we have to prove that G is bipartite. And we have reached here. This was the picture with which we entered the last video. We have two paths, P and Q. One path P, which is the shortest path from U to V, and second one, Q, is the shortest path from U to W. Okay. Now with this, we have taken G as a connected graph. So now we'll make two claims. Those two claims are very important. What we have done is we have chosen U as a vertex in the X, and V and W also as two vertices in X. What we are going to prove that is uh, this edge will not exist. This edge will not be there. If it is there, then we'll have a contradiction. Okay, finally only we'll assume that there is an edge and we'll get a contradiction. Before that, we have to do some initial preliminary works. So we have two parts, capital P and capital Q. First claim, I have told you that we'll be making two claims. Claim 1, UW1 section of P. Let me move to the picture. This is U, starting from U, you reach here W1 along P. Means over the what is the green vertices, you reach W1. Then similarly UW1 section, again you are moving from UW1 from U to W1, but I'm moving along Q, that means over the red vertices. Our claim is that both that sections, U moving from U to W1 over P and moving from U to W1 over Q, will have the same length. See, if not, what will happen is it will contradict the shortest path property of either Q or P. That means if one of them is shorter, I can reach from, suppose P is shorter than Q, then UW1 section means UW1 section of P is shorter, then the shortest path property of Q will be violated, because I can move from here, then reach here shorter than moving over Q. So shortest distance Q will not be Q, it will be another path where some part I can move over P, then reach W. So shortest path criteria of either Q or P will be violated if we assume that these two sections are different. That means UW1 section over P and UW1 section over Q. If we assume that they are of different length, then we'll have a contradiction. Therefore, they will be having the same length. That's the first claim. Second claim is that now we have the remaining section. That means W1U section. Let us go to the picture again. This is W1B section, and this is W1W section. This must be V. This is V, and this is W. W1V section of P and W1W section of Q are of the same parity, not same length. Previously, same length. Parity means they will be having either odd length or even length. That means if this is odd length, this also must be odd. If this is even, this is also even. That's what we are going to prove. So let length of W1V section of P be L1, and the length of W1W section of Q be L2. Then, since the length of P is taken to be small p, which is E1, we will be getting L1 plus K equal to P, where K is that UW1 section over P. Then similarly, moving along with Q, if that is this is L2, that is W1W section, This is K because using claim 1 we have proved that they have the same length. So L2 plus K is equal to Q. This is the length of Q. Then subtracting, you will be getting L1 minus K will be vanished. L1 minus L2 is equal to P minus Q. Both of them are E1. Therefore, L1 minus L2 must be congruent to 0 mod 2. Therefore, L1 is congruent to L2 mod 2. That means remainder when you try to divide L1 by 2 will be same as remainder when you means both of them will be either even or both of them will be either odd. Therefore, we establish claim 2. Claim 2 says that they must be of the same parity. Now last, we come to the end of the almost end of the result. Now assume on the contrary that there exists an edge VW. That's the figure. Let us go to the figure first. Now we assume that there is an edge here. If on the contrary, there is no edge, we have to prove that there is no edge at all. But if there is if we assume that there is an edge, VW is an edge, we'll arrive at a contradiction. That's what we are going to get. Okay. Okay. Now assume that contrary, there exists an edge VW, which is VW. Then what we get is you will be getting a cycle. Means then I'll show you the thing, right? Okay. Let me add a page then. Okay. That means here is this was your W1. Here is your V. Here is your W. I'm moving over this one. That's of length L1. This is edge. This is just for the sake of having the edge. So it's of length 1. Then move from here to here. This is L2. So this should be moved over P. This should be the edge newly created. This is actually from here to here it is Q. Therefore, from here to here it is Q inverse. So W1 section of Q inverse, this one. This is WV section of W1 V section of P. Then W is the newly formed edge. Then this is L1, which is E1. If it is E1, this is also E1. If it is odd, this is also odd. Therefore, E1 plus 1 plus E1 is odd. Odd plus odd is also E1. E1 plus odd is odd. Therefore, totally what happens is, okay, that I have explained. L1 plus 2, L2 is E1. Therefore, L1 plus L2 plus 1 is odd. Therefore, we get the cycle, that cycle of odd length. But we have assumed that G has no odd cycles. Therefore, such a cycle will not exist in G. Therefore, that contradiction shows that there is no edge connecting V and W. Therefore, whenever V and W are chosen from X, there is no edge. Similarly, we can prove that there is no edge for the vertices inside Y. Therefore, V equal to X union Y makes G a bipartite graph. Now we have started with a case 1 in the previous video where G is connected. If G is not connected, it means it is disconnected, then let G1, G2, etc., G omega be different components of G. Each component will be connected. As each Gi is connected, applying case 1, we have already case 1, means in the case of connected graphs we have already proved. So let this be the partates for the Gi, then form a partite set for Gi, then you take the union of all those partitions, then this xy, this pair xy will form a partition for the disconnected graph G. So that establishes the theorem completely. If you have any doubt, you can ask through our WhatsApp group. Thank you for watching.